So in this video, we're gonna talk about finding the torque as well as the direction, okay? As well as the direction. So if I'm looking at this, I have this yo-yo here, and I'm pulling, right? Here's my force being applied at some point, and we're pulling on the force, okay? And I want to find out what is the direction of the torque. Well, if I choose this to be my location, and by the way, guys, the point that you choose to be your location A does not matter. You just have to choose a point. Now, some places are harder than some, okay? Some places are harder than some, but again, I typically like to choose a point where there's very little, very little torque happening, okay? And so if I look at this, if I choose this to be my location A, well, there's a point of my force. And so the vector with respect to the vector of RA always go from the point. So this is my vector RE. So I always go from my location A to the point of where the force is happening, similar to when we talked about the direction of the angular momentum. And we say it's always from A to where the momentum, the point of the momentum is taking place. And so there's my vector. And so if I want to find the direction of the torque, okay, and by the way, this problem is given in the XY plane. Okay, so if we know this is in the XY plane, then we know the direction of the torque is a cross product, and so we're crossing them, and so we know the result of the new vector has to be perpendicular to both. And so if that is true, then we know we're going to be in the z direction. Now, which direction is it, positive or negative? That's where we use the right hand rule to find out. And so remember now, the only thing I do now is just take my force and take them tail to tail. So there's my force. This is my force with respect to location A. This is my force of A. Okay, and I just simply stick the tail of my RA at the tail of F. So here's my RA, and I'm sticking the tail there. So there's my RA. Okay. Well, that's nice to know. The right hand rule says I'm going to stick my hand in the finger in the direction of A, in the direction of RA, and curl it into the smallest angle. So if I stick my finger like this and I curl it, you can see that I could curl into the smallest angle, and stick out my thumb. My thumb goes all the way up. Okay. What does that mean? It's going out of the board, or direction in this case will be a positive Z. Okay, because remember, we're in the XY plane, so we're going to get something that's perpendicular to both. That's got to be in the Z direction. And again, we just defined out of the board as being positive. Okay, so there's a positive Z out of the page. So that would be the direction of the torque. Now, what is a numerical value? Well, we're given R and we're given A. So we know the torque about A is equal to some location RA crossed into the force. Okay, and so if I'm looking at this, simply we're just multiplying. So I take 0.005 meters and multiply that by the force, which is 6 newtons. Okay, I multiply that by the force, which is 6 newtons. I get my torque with respect to A to be approximately 0.003 Newton meters. Okay, so again, this is how we find the torque. This is how we find the torque with some sort of direction. And actually, guys, you'll be given several problems like these where you have several directions. You have several force, and with respect to location A, you got to find the torque. And this is how you do it. You draw your arrow from you draw your arrow RA from your location to the point of where the force is happening. You stick them tail to tail, and just simply use your right hand and cross into, starting from R, cross into the force.